AP Stats team, this is session number 1, preparing for our final. We're going to go over some questions. I know Jordan's here. I know there's a couple other people coming, but glad to have you here, whether live or by podcast. And so we're going to get it rolling. Right now, we're just going to go over concepts. And if we go to some multiple choice or FRQs, we might do that and go from there. If we do take multiple choice or FRQs, we're going to go off of the bottom one that says extra multiple choice or extra FRQs. Hopefully, I'll show you a video before we get started with those questions. All right. So with that being said, we're going to do it right behind me, and we'll get started. Jordan, you got some?
Can we do the where it's like x is less than like 5 less than x less than 7? Isn't that on the normal distribution? On a
Yeah. So okay. So first off, we have a lot of questions on this normal distribution that are here, right? First off, the notation that a lot of times we give is the big N with the mean, and then comma the standard deviation, right? A lot of times that's how we write it. Now, within a normal distribution, we've had a couple of things that that have happened from it. First off, we have the basic version. The basic version just gives us what our regular mean is, right? And when we have our mean, we have the rule where we have one standard deviation. So if I have the mean plus 1 standard deviation and minus 1 standard deviation, the area between here, first of all, the whole area is what?
100%.
100%, or a lot of times we'll say 1.00, right? Which that comes in with the sampling proportion of the sampling distribution, because again, we say that like percentile, right, is related to 100% or 1.00. So we have 68, that's here, right? And then from 2 standard deviations, right here and right here, we say, what's up, Max? We say that if this is 68, then between 2 standard deviations is 95%. And between 3, that's really, really small, right? That's called 99.7%, okay? We call that the empirical rule, all right? Now, that's just building up. That's for everyone at home, because I know that's not your question. The question that Jordan says is, what if I have, and I'll make this up, let's say we have the mean of 100, standard deviation of 10, and I say, okay, and I'm trying to think of what this could be. Let's do grades. So let's say the average grade was an 80 on the last test. Standard deviation was 10, okay? And let's say what are the, what percent of people made between a 70 and a 85? Is that what you're talking about? Okay. So what we'd be looking for is this: the x value would be greater than 70, and it would be less than 85, right? Okay. Another thing before I go into that, that's very important. Is this a continuous graph or a discrete graph? Discrete. It's actually continuous. If you think about it, can I do? This is just a side note because we're going to come to this. The normal CDF versus normal PDF, right? What can I not do?
You can't do
PDF, because that PDF means one value, right? Whereas, and we can do binom PDF because we could find one value, right? If we need to go through that later, we can. But CDF is this cumulative, right? Cumulative here, to where if I found like, what is the percentile of those that got an 85? We would have 85 and anything to the left of 85 shaded, right? But here we have the mean as 100, right? And if I was to shade this, and 10 is standard deviation, so, oh, I'm sorry, hold up, 80 was mean, I should change that. So this would be 70, and this would be 90. So really what I'm doing is I'm shading between, and this is what I would do on any problem, because just to visualize it, is anywhere from 70 to 85 right here. Take out the 68 because this doesn't apply. But I'm really shading that area in there, okay? Now, if this was a multiple choice question, it doesn't really matter to show word. You'll just go to normal CDF, lower bound, upper bound, mean, and standard deviation, right? But in an FRQ, we have to establish context. That's huge, right? And a lot of times they won't give you credit unless you actually establish it. So when we do this, if I was to find the area between 70 and 85, and it would say, hey, it's approximately normal, right? On the basic version. On that part, we would then say normal CDF, and I would actually put lower bound, comma, upper bound, comma, mean, I'm sorry, it's standard deviation. Mean, comma, standard deviation, right?
Yes.
And then I would actually plug it in. So I do normal CDF. Lower bound would be, what would that be? What would be the lower bound in this context? 70, right? Because that would be the lowest value. The upper bound would be 85, good. The mean would be 80. Yeah, I'm sorry, messed up. I keep doing 100. And standard deviation's 10. And once I plug that in, you should get a value, right? That tells you, it's like, trying to think, it would be probably like point. I don't even want to try to guess. Let me try to put this in real quick, and y'all can put it in too. And that way we can kind of tell ourselves what it would be in context and kind of help ourselves on that. So we've got here. All right. And also, just at home, if you're at home, this might be a good idea to just kind of remember some of the calculator things. I've had 3 people take it already, and out of those 3, the number one issue was not concepts, it was having the ability to complete it. In terms of, a lot of times if you don't know what it is on the calculator, you can waste time on that. So that's something that I would do.
Just really quick, like what's on this test? How many multiple choice? How many free response?
Yeah, good question. So it's kind of like 3.5 FRQs, because there's 2 regular, and then there's a third one that just goes a little bit deeper. I will tell you this, but the third one, if you do at least the first page, that's the part I really want you to do. You can get to the last page. That'd be awesome. Okay. What I'm going to do is I'm going to grade it as normal. Now the normal on this is different, right? I grade it like an AP exam, square root your score, and then multiply by 10. But for the FRQs, it's going to be graded. You're going to see it graded. So like an E, P, and an I, right? And so in order to get an E on an FRQ, you have to have a lot that's involved in that. So I would just practice maybe that context, and then from there, then I'm going to just use the scores and just see where we're at, and then kind of go from there. If everyone didn't finish, then I'll adjust that accordingly. But you just want to try to do as much as you can there. Did y'all plug that in at all?
Yeah, it was lower round was 70, upper round was 85, mean was 80, and 10. I got 0.534.
Good.
0.533, sorry.
533,
Yes.
Perfect. So once I plug that in, that would be my answer. I'd say 53.3%. That's there. Now, putting that in context, once I do this, again, probably be a point here, probably be a point for establishing normal CDF, then writing it in, putting this down, and then putting down what does that actually mean. And so what do you think that number is talking about in this context?
53.8% of students score between 70 and 85.
Correct. That's exactly right. Does that make sense there? Now, this would be like the normal distribution. Do y'all understand how this ties in with what we just did in chapter 7? Or do y'all want me to go into that conversation?
How did you do on chapter 7?
You want me to go over that? Okay. That's fair. That's absolutely fair. So this right here is actually very similar to what we talked about before. Let me see if I think I had a question. Let's do this. I'm going to get this question here. What's up, Alyssa?
Hello.
Alyssa's in the house in the podcast.
Barged in.
She came rolling in.
I'm ready. I'm ready to come see Santa.
She did. She came rolling in.
Let's go now.
I'm very excited.
If you want to, Alyssa, would you mind, because Alex is taking that test back here, would you mind, Alex, is it okay if we help?
Yeah, sorry.
move your stuff? You're good. And this is the non-calculator.
Yeah. Can I come back to that challenge probably 5 times again? I tried it. I got stuck, but
I'll put it right here, okay?
Thank you.
You're welcome. Okay, I'm going to come back to a question. The question I want to go to is one, well, I already podcasted on that one. Let me see if I've got one here. I know I've got it there. Let me just see really quick. What I'm looking at right now, and this would be a good idea for anyone, if you're looking at trying to get some extra practice, the extra multiple choice and FRQs, I would actually take that like the test. I would give yourself time on that and actually go through that go through that one there. And that's up to you, but that might help you with what we're doing on that. What we just did with the distribution, the normal distribution we just did, that is going to be very similar to one on number 3 on the extra FRQ. So if you want to make a note of that, what I just did on that one would be good. Yeah, very similar. Well, on the practice one, that is, you'll have multiple choice on there. The 3 that I gave you on the day of the test, and I don't have those with me. You can get those from other people if you've got them. Those ones are pretty good start that's there. Okay. And if need be, we can go over specific topics if you remember. I'm trying to remember what I put there. One was like a simulation and probability. I didn't put them on campus. I put them on the top, like where the Family Feud thing was. I said, hey, these are the 3. So if you've got those, that's a good place to start. Very good place to start.
Listing the expected value, probability plus simulation using table 3 and compare distributions, that one?
Correct. Correct.
Are you in the group me? Well, you said that. I need that picture of where it was the 5 things that we need to go over.
Wait, I don't know.
Wait,
I remember you taking a picture of
I feel
that.
like I took a picture. I was wondering if I took note because sometimes I write stuff down. Sometimes I take a picture.
The 5 things I think I've got here, y'all. I think I've got the 5 here. The other ones I don't. Yeah, right here. Or like the notes for the exam.
Yes, that.
Right here, if you want to come and take a picture of that, that's fine. The one that I wanted to do, so Max, you were right. This one is one that's not bad, right? Because we've been doing it a whole lot. The confusion came when we took the normal distribution.
Yeah.
Yes.
And what we ended up doing is we ended up taking I want to make sure it's on there. Perfect. We ended up taking the sampling distribution, which first of all, what is you're confused on that? All right, let's just have a conversation then, okay? Let's do it. A sample distribution compared to a sampling distribution. What's the difference?
Sample just one group.
Good.
Oh yeah, and sampling isn't like multiple groups.
It's like
You choose
multiple groups
from-
of a sample.
Correct. Yeah. It's like a sample of a sample. And when we talk about mu of p hat, that's here. In fact, let me do this. Let me write this down, and I'm going to get this here in just a second.
And is the exam like mostly? It's like all spread out, right? Like yearly or past few chapters. It's not like mostly chapter 7.
Yeah, it's kind of. I don't want to say random, but it kind of is. It's just kind of throughout.
That's fine.
Yeah. As long as
That's
it's
fine.
not
Like
like
me. I'm glad that you're approving that.
Hey, it works.
Here.
Go ahead.
So I think we struggled on the binomial, right? And the sampling distribution, right? What's the difference between both of those? How do we solve both of those and go from there? So let me do this. Let me give this problem here. I did podcast on this, but I think it might be helpful to have y'all in here to answer questions, okay? So this one is from the cumulative test FRQ, but this gives the following information. It says this: the mean number of pages in a city library, okay? So what I do, this is just me,
Oh yeah.
where N is the city library novels, okay? All right, and this is what I did to break it down. This is how I put it here. It says that 500, the mean number of pages is 525. So the mean, because it's in the population, is 525 pages, okay? All right, it then goes on to say it has a standard deviation of 200, right? All right, so it then goes on to say, now this is a side note because I'm going to come back to this, okay? But it then goes on to say that approximately 30% of the novels have fewer than 400 pages. Okay, so 30% of the novels have fewer than 400 pages, right? So 0.3 is a proportion, right? Is that P or P hat?
P.
P, because it's talking about my population, okay? Does that make sense?
Yes.
All right. Alyssa, you can move the chair too if you want to. The reason why I have it here is just so it can see this board, so they can see it there. So this would be 0.3, have fewer than 400 pages. It then goes on to say Suppose that you randomly select 50 novels from the library. What does 50 mean?
That's your in.
You're small.
50 is like my random sample. So from that, I got this information. Anytime that I can get this information, it at least helps me to see what do I have and where am I going to go, okay? Now the question asks, what is the probability that at least 20 of the novels, okay? So 20 of these novels, right? All right? What is the probability that at least 20 of these novels? Now question, what does at least mean?
There could be more.
Yeah, so it's really where x is greater than or equal to 20, right? Of the 50. Okay, perfect. All right, and it says, what is the probability that at least 20 of the novels have fewer than 400 pages, okay? Is this a sample distribution or sampling? How many samples did we take? One, right? Okay, so we just took one. So if they asked that, it would just be the distribution of one sample, right?
So if it was like we got, because the problem is that they're picking 50 books randomly, right?
Correct.
If they said we picked like 3 groups of 50 books, would that be sampling distribution?
Say it one more time.
It's like if they were like we took 3 groups of 50 random books, would that be sampling distribution?
Then we would be headed towards a sampling distribution, right? Really, a true sampling distribution is one where I take every single possible sample of 50 out of that population. Is that possible? Not really, right? It's not possible. However, we will still approximate with a significant amount of samples within samples. Am I making sense there? Okay. Now the question is can I, this is where it becomes a little bit tricky. Can I use a binomial here?
That's your bins.
Okay, let's check it. Can we check it? Okay. So the question is can I use bins? That's the question. Is it binary?
Yes.
Yes, it is. Because you either have 400 or you don't have 400 pages, right? Okay, question 2. Is each novel independent?
Yes.
Yes, it is. And do we have a set number that we selected? Yes, we do. Okay. So this would be number. This is true. And is the success percentage the same every time that I select? No, it's not, right? However, we stated that if the 10% condition is met, guess what we can do? We can say that it's large enough for it to be successful. So we say 1/10 of my population, is that greater than or equal to little n? Well, little n is 50, right? What's big N?
500.
It's actually,
You don't know.
it's very large, right? It would be very large. It would at least have to be 500, but the novels in a library are going to be a lot larger than that. So we could just put library novels there. And we'll just say check and just say that we assume that the 10% condition is met. Therefore, the success percentage is good. So can we use a binomial here? Yes, we can. Okay? Yes, we can. Now, this is where it becomes a little bit tricky, okay? This right here is binomial, right? Would we use, based on the information given, could we use binomial CDF, cumulative, or PDF, which is one value?
Oh, CDF, because
Correct. Why?
it's not discrete. It's continuous.
Okay. All right, hold on just a second. I want to make sure of this, okay? Is it really continuous? All right, so think about this. I have 50, right? What is the probability that at least 20 novels are greater than 50? Isn't that a discrete value? You can have 20, 21, 22. Can you have 21.5?
No.
No, you can't, right? You see that?
So you use CDF?
Well, the reason why we're using CDF is because it's at least that amount. Now, if I said, what is the probability that 20 out of 50 have fewer than 400 pages? At that point, I'm looking for one value. Does that make sense? So because I'm looking for one value here,
I got you.
at that point, that's when we're thrown off to where we only can use PDF.
Okay.
Does that make
If it's
sense?
like exactly 20 books? Or no?
If I said exactly, that's perfect. Okay. Why do we not use normal PDF? But because when we do this, right? Hopefully y'all can see this. when we do this graph, can I say, what is the probability of one event occurring in a normal distribution? I can't, right? Because what do we usually say?
So
It's like an area, right, in between. Because this is continuous, I can't use that there. Does that make sense? Okay. So here's where it becomes a little weird. There's two possible answers for this, and both are accepted. As long as you defend your answer, you're good. For this one, we could use binom what? It'd be CDF, right? Because it's cumulative, right? Cumulative. So we could use binom. I want to make sure I put this down there. There we are. Over here, we could use binom CDF, right? Okay. Now, when we plug this in, remember that just like with the normal distribution, even though it's not the same, with a binom CDF, it's everything to the left of that value, right? Or equal to that value. So we can't use 20 because we want something that's greater than or equal to 20. Does that make sense? So when we talk about what is the probability, right? And I'll kind of put this here. What is the probability that x is greater than or equal to 20? Really, I can't do it this way. I have to do 1 minus binom CDF, right? What do I put in the first value there on binom CDF? I think this one's just a little bit different.
Trials.
It's the number of trials, and again, you have to plug this in, right? You have to actually write this out. So number of trials, which would be what? That's like little n, right? Okay. So we would say 50. Okay. So I'm going to rewrite it down here. So if I was doing an FRQ, I would know 1 minus this, right? So 50 to your P, which would be the probability, which is 0.3, right? Comma, and actually I should probably put my probability, which is P. And this would be 0.3 down here where I put the values in. And then the comma, and I think it's like X value. Is that what they put? Yeah. I would just put my X value, which in this case would be what? Again, remember it's any number that's that number and less than, right? We're trying to get what is the probability of getting greater than or equal to 20, right? That's why we do 1 minus, because this only calculates what's to the left of that value. So this, when we plug this in, don't we do 19?
Oh,
yeah. Does that make sense?
Oh, yeah.
That was okay.
Does that make sense there?
Yeah.
So we're going to do 19 here. And when we plug that in, 1 minus the binom of CDF, 50.3 and 19, what we can do now is when we plug that in, we can find what that proportion would be, okay? And so when we do that,
0.9151.
is it point, what was it again?
Oh, I didn't subtract yet.
And then subtract that, what would we get?
0.0848.
Great. Okay. And then in context, you would put it in context, right? So we can expect that there would be a 8.48%, or you could say a proportion of 0.0848 of at least 20 out of the 50 books being fewer than 400 pages. Okay. Basically, you're restating what we already were trying to find in the first place. Okay. All right. So you see how in this case, because it followed bins, we can go, and again, 10% condition, we just followed what it would be in terms of the binom CDF or in this case, yeah, binom CDF that's there. Does this make sense to y'all? Questions on this?
No.
All right. These were the two areas we struggled with most, so that's why we're hitting it. Here's the deal. I can do a second option. Okay. You might say, Coach, which one do I use? Do I have to do both? No, you don't. The AP exam will allow 2 different answers on this, okay? Does that make sense?
Mm-hmm.
All right? So what we're going to do is I'm going to go to chapter 7 by utilizing the same problem, okay? Same problem. All right. So chapter 7 said this, right? Within a sample, what we can do is we can find what p hat is here, okay? Now you might say, how do I find what p hat is? P hat would be the proportion of the sample, right? How do I find the proportion of the sample over here? What about? So it's at least 20, right? So we could really say that this is at least 20 over 50, right? So what's p hat?
258.4.
0.4, good. So we're really finding the probability, right, where my sample that I'm going to select out of the 50 is greater than or equal to what? Because now we're talking proportion, not whole numbers, right? So what do we get at 0.4? Good. So that's what we're looking for. The probability or proportion that my sample proportion is greater than or equal to 0.4. Okay? Does that make sense? All right. So question. Does this involve, well, first off, can I approximate this using a normal distribution?
You have to check.
You have to check what? CLT, right? Okay. And this is n times p has got to be greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. Okay? If this is not true, the only correct answer would be your binomial that we just did. Okay? We can check this. N times p would be 0.3 times 50, which would be, is that 15? I think that's, so this is 15 greater than or equal to 10. Is that true? Yes, it is. Okay? And by the way, I know this is tough right here. I know this is tough. That's why we're going through it. Okay?
This is still the same problem.
Same problem. What I'm saying is you could take it two ways.
Oh, okay.
I'm showing you that you could do one way. It works the other way as well. Does that make sense? Now, if I said, what if x is equal to 20? Okay? Here's a really good question. If this said not x is greater than or equal to 20, what if I said what is the probability or proportion that the number out of 50 would be 20 books that are less than fewer than 400 pages? Would I be able to use this?
No.
Why?
It's not continuous.
Great, because at that point we're just looking for one value. I can't use a one value for a normal distribution. I would have to go to the binomial.
And where did you get the 0.4 from again?
0.4 came from the proportion that was created. Instead of saying this is 20, which is true, we're going to change this to proportion because it's 20 out of 50.
Okay.
So 20 over 50 is 0.4. That make sense? Jordan, I'll keep podcasting, okay?
Thank you.
If you got other things, throw my way, okay?
Okay.
So at this point, we're just plugging in and seeing are these things true. So we plugged in n times p, which was 15, is greater than or equal to 10. That's true. The next one is 50 times 1 minus 0.3, right? 50 times 0.7, which is 35. Is 35 greater than or equal to 10? Yes, it is. So since both of those are true, the central limit theorem allows us to say that our sample distribution can be approximated with a normal distribution.
Would there
Alyssa?
be a time where one of those isn't true, but one of them is?
Yes. In
Okay,
fact,
that
if
was
you
my
go
guess.
back to chapter, when we did the binomial, chapter 6, okay? As I went back, there were a lot of great questions some people brought to my attention. That's like, why can't I use the normal distribution with this? Well, I said, hey, let's plug in and see, okay? So we plugged in and saw that actually one of these failed. So since it failed, we can't approximate this with a normal distribution.
So if
Okay.
one's right and one fails, you can't do it at all.
I can't do it.
Okay.
It's not large enough to be able to say that, okay, this sample distribution would approximate as normal. Now, you're going to see how in both of these scenarios, the answers are off a little bit, but that's okay. Both of them would be okay. We're not as concerned with the right answer as the right process and the right work.
And where would you go from there? What's
Okay.
your would you do?
Yeah, so now we're actually doing exactly what you're good at. The only difference is now we're not going to between two numbers, like two grade levels like we did earlier. Now we're talking about our proportion. So what we mean by that is now we're going to do n parenthesis, the mean of p hat, comma, standard deviation of p hat. All right?
Okay.
Now, to find the mean of p hat, we'll just put it right down below. This is straight from the formula sheet, so don't freak out.
Right? So
Equals
0.3.
p, good. And the standard deviation of p hat is the square root of p times,
1 minus.
there you are, divided by n, right? Now, question, because this was on the test, as n increases, the number in my sample increases, what happens to variability? Without looking at this formula, if I increase the amount of samples I have, variability does what? It decreases, right? Does that make sense? So just be leery of that. So as n increases, think about it. If I divide by a higher number, this standard deviation would get smaller, right? And standard deviation and variability are the same type of word. Variability just means the spreading out of data, right? So when we say that n increases, standard deviation will decrease. That was just bonus for what we just did, okay? It's not anything on this that you need to know. So when you plug this in, the mean of p hat is p, therefore this is equal to 0.3, right? So 0.3 is my mean. Now the standard deviation we can't use because it has to provide, or has to meet what condition?
The 10%.
10% condition. Now, I'm not going to go into that because we already did that with the binomial, right? So you don't actually have to go into that. So we can just say that it does meet the 10% condition. You would need to say that and then also show me that it actually does, right? So once we plug this in, we put 0.3 in for p. 1 minus 0.3 would be on top, divided by 50, right? And we can do that. And when we do that, we get I love doing these because it makes you look really smart.
Point
You know what I mean?
0.065.
0.065. Good. Okay. So what do we have? Well, literally, we're coming right back to what we were talking about earlier. The only difference now, and I'm going to erase this here. Hopefully, you can go back in the podcast here. But once I get this and I establish what's below, now the mean of this would be 0.3, right? The standard deviation, you don't even have to plug that in to get credit. You don't actually have to add each value. Just shade what you were trying to find. So if we're trying to find what is the probability that the sample proportion would be greater than or equal to 0.4. So 0.4 would be somewhere along these lines right here. And we would be shading anywhere that's to the right of that value. Okay? We go right straight back to what we did earlier with normal CDF. We establish context of lower bound, upper bound, mean, and standard deviation. And then we just plug in. So my lower bound is 0.4. Upper bound is just a high number, right? Doesn't matter. Mean is 0.3. Standard deviation is 0.065. Okay? Now, if you remember, the binomial was like 0.08 something, right? When we do this, I don't remember the exact number, but I know that it's a little off. It's going to be a little off. It's going to be like 0.01 or 0.02 off. But that's okay. Again, it's more about, this is an approximation, right? We talked about that. It's not an exact value. So both of the answers of using either a binomial or using the normal distribution, both are acceptable, okay? All right, that was a lot of information, but I'm hoping that kind of hit some of the areas we struggled on through that one problem. Do y'all have any other areas that you're like struggling on? Did you get that, Max?
Yeah, I did. Also, so like, say it wouldn't meet, like, say if it didn't meet like the potential condition. Yeah. What would you do?
At that point, it's not large enough to assume a binomial and to also use the standard deviation formula.
So what would you say?
I think, I don't want to guarantee this. I would just say that within the FRQ problem, and then I probably would stop. This is probably what I would do. Probably in an FRQ, it would not happen in that way. You still have to say it. Does that make sense? Normally, the population is like the city library novels or something so large that it's going to be met.
Okay.
The one area it could come up with in where it fails is in a multiple choice question where it says, why is this not able to be used with a binomial, or what condition does it fail? And so you would, maybe answer it that way. I could see someone doing something like that.
Okay.
But that'd be it. Do you have any other areas that you're like, man, this is an area I struggle with at all?
I'd probably say the one I was really confused by was the probability, but unit 5.
Unit 5?
Yeah.
Absolutely. Would it be something you want to do like example problems, or do you want me just to go over specific areas within the probability?
Even specific areas, rules sort of,
Yeah.
things you have to follow by.
Absolutely. Okay. So the one thing you need to know is that when two events are mutually exclusive, they are not independent. Okay. Now I'm going to state it. I'm going to spend 2 minutes on that. But if all you remember is that mutually exclusive events are not independent, you are okay. All right. Does that make sense? Because I don't want to spend another 25 to 30 minutes on something that's a one question, right? but I'll tell you it, okay? First off, let me go on just quickly. 2 things you need to know big time, okay? The probability of A and B, this is the formula for this, okay, is the probability of A times the probability of B given that A occurred, okay? All right, that is the formula for A and B. Now, when I have the probability of A or B, it's the U, right? You call it union, right? In this example, we would say this is intersection. By the way, a Venn diagram of this, and would be shaded there. And with the or, which is union, they would actually shade both A and B because it's A or B that's occurring.
It's like
Okay?
none. But where there's just 2 circles and they don't intersect at all.
Yeah, we call that mutually exclusive. Okay? So you're saying this, that, okay, what happens? So yeah, so we would say these 2 events are mutually exclusive because there is no intersection. You're going to see that through the equation here in just a second. Okay? All right? The probability of A or B, the equation for this is P of A plus P of B minus the probability of A, and B. Okay? Now, here's what I would do. Anytime that they either give you this part, they say and, they say or, write out the equation first. Does that make sense? You write out the equation first, it's going to be a lot easier. If you need to, also write out what does A mean, because it could mean different, something different in a different context. Same thing with B. Okay? Now, with these 2 equations, let's talk through a couple things. When we talk about something that's mutually exclusive, what we are saying is this: probability of A or B is equal to the probability of A plus the probability of B. We exclude P of A and B. Why do we exclude that within the formula? If it's
A or B, there's no middle sharing. It's either that circle or that circle. You're not including the middle part.
Yeah, there's no middle part, right? So that means the intersection, where the 2 circles intersect together, there's no middle. There's no intersection. So if it's mutually exclusive, this part is actually 0, right? So you don't have to include that within the formula.
Or if it's mutually exclusive, you're going to use that formula?
Correct.
Or if it's independent, which formula would you use?
If it's independent, we're going to look at the top one, okay? So if we say, are these 2 events independent? So real quick, I think this might help. If something's mutually exclusive, it looks like this, right? No intersection. The equation for that is the probability of A and B, the intersection, is equal to what? Oh, that's a good question.
It's equal to,
There is one.
Good. So it's equal to 0. Great. Okay. Does that make sense? It's basically what we just said, right? We use the modified formula because there is no intersection. Okay? That's mutually exclusive. That's the definition of mutually exclusive. All right? 2 events that have nothing to do with one another, right? Now, when we talk about independence, independence is different. That states that what I do on one event does not have any impact on what it does on the other one, right? And so on and so forth. So, for instance, if I look at it up here, the definition for independence, instead of giving you a picture, okay, because that can get kind of confusing, really what that means is the probability of B. So I'm going to do independence down here. The probability of A times the probability of B equals the probability of A and B. You say, Coach, what are you talking about? Well, notice I can exchange probability of B with probability of B given A. Why?
Because it's independent. So 1.
It doesn't affect.
So probability of B is going to equal probability of B of A. Or would it be the same if it was probability of A equals probability of A when B is given?
Correct. That's correct. Those are independent. Does that make sense? So we would say, what is the probability of B given A equal to in an independent case?
Probability of B.
Probability of B, right?
Yeah.
Does that make sense? So if I shoot a free throw, what I do on the second one has no impact on what happened on the first one, and so on and so forth. Okay? That's independent. Mutually exclusive is there's 2 events that can't occur at the same time. For instance, if I draw a card from a deck, there's no way that I can get a black card and a red card. Those are mutually exclusive events. Does that make sense? Okay. So let me explain quickly, just real fast. If things are mutually exclusive, how are they not independent? Or how are they Yeah, how are they not independent? Okay, I'm gonna say that right. All right. So if I say that two things are mutually exclusive, such as this, okay, and I say, okay, this is A, and this is B. What does mutually exclusive again mean?
It means that they like don't intersect. I don't know. That's the only thing. They are dependent. I don't know.
Yeah, there's no intersection. You said that right. You said it right. I just wanted to make sure you got that. Okay. So if these are mutually exclusive, they are not independent. What does independence mean again?
Independence means that one doesn't influence the next.
Correct. Okay. So question.
So like, wait, can you just give like a definition of mutually exclusive real quick? It's like there's no part whatever.
Mutually exclusive means that these two events cannot occur at the same time.
Okay, gotcha.
Does that make sense?
Yes.
Okay. They can't occur at the same time. So think of like a red and a black card. Okay.
Mhm.
And I draw it from the deck. There's no way that both of those can occur at the same time. Okay. Now here's the question. If I state that A happened, does that have an impact on what happened with B?
Yes.
It does, doesn't it? Doesn't it? Because if they're mutually exclusive, it means there's no intersection. If I said that A actually did occur, that I actually drew a red card, right?
You have more chance to draw a black card than this.
Correct. There is a higher likelihood. It does have an influence on that. That is one basic example. I don't want to get into the huge in-depth analysis of why two mutually exclusive events are not independent, but that would be the easy way to just remember that. If they're mutually exclusive, since they're separate, there is no intersection. What happens on one, if one event occurred, it will have an influence on what happens on the second one. Okay. In fact, if I said that I drew a red card, right? In that same, so if I say, yeah, I drew a red card, the probability on that same one that you would have drawn a black card would have been what? It'd actually be 0. Because if I said it was a red, it can't be a black as well. Does that make sense? Does that help you?
Yeah.
So that's basically, this is probability at its finest. There's a lot of other stuff that you can kind of go into, but that's kind of the big part there. Listen.
Well, we need to know anything with like dependent, or like, is there even like one?
Something that's dependent means that, well, this would be dependent right here, what we just said. If it's not independent, it's dependent. If I say the red card was drawn, that has a direct influence on the fact that black card would be, the probability of drawing a black card would be 0 because they're mutually exclusive. Does that make sense?
Yes.
So that's what we're looking at there. Okay. For this one, I'm going to do this. Would you mind if I kind of use a problem and maybe we can talk through it on this one? Let's go to the, if you go to your Mac, I wish I could throw it up there. But we're going to go to, trying to see one that's like a good probability one on the practice one. It kind of, as it goes through, by the way, in this practice one, you'll notice that as we go through it, there are, they kind of like gradually increases. Does that make sense? Like, so it goes from chapter 1 to 2 to 3 to 4 to 5. So right now we're like on chapter 5, okay? Look at 23 on that one. It says this, okay? And if you're looking at it at home, it's at the very bottom again. It's the extra multiple choice that's there. That's the one we're looking at, okay? All right, this one says, suppose that A and B are independent. Okay, stop right there. What's the formula for independence?
A, P of A
Okay,
times, or
we can say the probability of A and B is equal to the probability of A times what?
P of B.
Nice. That's the definition of independence, okay? Because there is no probability of B given that A occurred because they're independent. It doesn't matter. So now we've got the probability of A is 0.2 and the probability of B is 0.4, right? All right, we're good? Alex, are you good on that?
Yes,
Great. Thank you very much.
thank you. And I put my review over there too.
Perfect. Thank you. So it asks this, though. Here's the definition that's true, right? This is true up here, okay? The problem is that they ask us, what is the probability of A or B? Now, does it say it's mutually exclusive?
No.
No. Do y'all see what one I'm on?
Yes.
I think it's page 11, yeah. 23, page 11 on the bottom. So since we don't know this, let's just plug in the formula that's given on our formula sheet, P of A plus P of B minus the probability of A and B, right? All right, so we're trying to find this part here. Now, can I plug anything in? See, Alex?
Yes.
Yeah, what can I plug in?
0.2
0.2 plus,
0.4
good.
minus,
I don't know that, do I?
oh yeah.
But what did I know? What did it tell me at the beginning? They were independent. Remember, this was the formula for independence, right? You see how if you take this whole big problem, like what it says, it's very confusing. But if you break it down, that it's independent first, right? And then we're trying to find this part. We can find what P of A or B is, right? But first we've got to find what the P of A and B is. So we can find that by plugging it in. Because it's independent, we can simply plug in 0.2 times 0.4 to get what P of A and B is, and then just simply plug it into the bottom formula. Okay? Does that make sense?
Mhm.
So when I plug that in, I think it's like 0.08, right? So 0.2 plus 0.4 subtracted by 0.08 would be 0.6 minus 0.08, which is it's like 0.52, right?
Okay, yeah.
And that's what we would do in order to solve it. If it was an FRQ, I might organize this maybe a little bit better, maybe describe a little bit better, but that would be what we would be expecting there, okay?
Mhm.
All righty, go ahead, yeah.
On this, can you just draw out real quick, like, when you draw, like, the box with the circles, like, it looks like a Venn diagram, you know what I mean?
Say that one more time.
Like this. Like that. How does it work when, like, you just subtract some of it because, like, someone's in the middle? You know what I'm talking about?
Yeah, you're talking about this one where we subtract the
Yeah,
intersection.
Yeah, like when you draw it out.
Here's
So
what
it's
Max is saying, and I think it's a great question. When I say what is the probability of A or B, really we're highlighting A, and it's got to be or B.
Mhm.
The problem is I can't say P of A plus P of B equals this or, because what I'm doing is I'm counting, because this is not mutually exclusive, I'm really counting this area twice, if that makes any sense. Because I'm taking A, adding B. Since I counted twice, I have to subtract the one intersection. Does that make sense? That's why I subtract one of those to get to what really is this. Really, or means this area plus the middle plus the right
Yeah,
side.
but yeah, because you're double counting it. Though, right?
Correct.
So, like, when you draw it into the diagram, how would you just subtract the middle part out from each side? Like, so if it was like the left side was 0.6, the right side was like 0.3, and the middle is 0.2, like the outside was something. How would you?
Yeah, that's a good question.
Do you like get what I'm
I
saying?
get exactly what you're saying. So he's saying, Max is saying this, if this area right in here is 0.2, okay,
Mhm.
but the probability of all of this is 0.6,
So it'd be
0.6
0.4.
minus 0.2 is 0.4 is just the left side, got me?
Mhm.
If this right side was 0.4, or I'm sorry, this whole B part was 0.4, I subtract 0.2 from the center to get 0.2.
Okay, I got you now.
Now, this is a Venn diagram that, I mean, it makes it easy. So if I say what's the probability of A or B, I'd say 0.4, which was the left side, 0.2, which was the middle, 0.2, which was the right side, added all together would be 0.8. In this context, would be 0.8 is probability of A or B. Does that make sense? That would be the visual part of that, okay? There's another probability one. Do you want to do it real quick? Let's do 24. Let's see if y'all can talk me through 24, okay? And if you're at home, you can pause this too. Try out number 24 and then get back to me because we'll go over it. But let's see if we can talk through it and we'll go from there. 24 says we roll 2 6-sided dice, one red and one green, okay? And red and green, I think, are irrelevant. We just know that one's red, one's green. That's it. Let A be the event that the number of spots showing on the red die is 3 or less, okay? And B be the event that the number of spots showing on the green die is 3 or more, okay? Use scenario 5-5. to find the probability of A and B. Now, before we get into any of that, okay, let's do this. Let's talk about what is the probability of A. And let's talk about what the probability of B is. Again, we're trying to solve for what the probability of A and B is, okay? All right, talk me through it. What would you do?
Would you, so since it says 3 or less, would you take it like 3 out of 6, or would you, like, if it's less, would you do like?
Yeah, and is that for A? Is that what you're saying? Okay. So if we have, in that, you can always write it 1, 2, 3, 4, 5, and 6, right? So it says 3 or less, right? So really, it's that.
Okay.
So what would it? So you're right. What would it be? 0.5, right? So this probability of A is 0.5. All right. Talk to me about B.
3 or more.
So would the highest
4
be
out of
like?
6.
Yeah. So this one, the second one says 3 or more. That's B. So what would that be on that?
4 out of 6.
Mhm.
So what is that? That's 20. Sure.
You can use your calculator for sure on that.
0.6.
6, but we don't say 6 3 times because we are a Christian school. So 0.67. Okay. All right. So we got our 2 probabilities. Okay. Now tell me what you would do now. I like how you broke it down.
So it's you're taking the probability of A and B. So you would do P of A
Mhm.
plus P of B, or is it? Wait, no, is it?
I think it's probability of A times the probability of B given that A occurred. Okay. All right. Talk me through now.
Okay, so
Its intervals are independent of each other. It would be independent, right?
Why?
Because like when you roll dice, like that doesn't determine like your next roll.
Correct.
It's, like, completely, like,
So if I roll 2 dice, now it doesn't say it, that's the tough part, okay? But if I roll 2 dice, the reality is that one will not have an impact on the other, and vice versa, right?
Yeah.
These are independent events. So because of that, right, we can then say that this is what?
P of
It's
P of B,
Yeah.
which makes this a lot easier, right? Because now we just do what?
P of A times B.
Yep, 0.5 times 0.67. And I think they actually did it in a fraction form, which made it a little tougher. If they put it in a fraction form, we know this was 1/2 and this was 4/6.
Yeah.
So you could just say the same as 1/2 times 4/6, right? And solve for that and go from there.
Let's say it wasn't independent, like just hypothetically speaking.
Mhm.
What would you do to find probability B when A happens? Is there a formula for that or no? Or which one's worried about?
If I was trying to solve for that, right?
Yeah,
That's a good question.
Like,
And I think this is 1/3, right? Just so those at home have it. All right, so what Max is saying is, let's come back. By the way, the context of the problem would be probably different.
yeah.
But if I was solving for this here,
Yeah.
the formula to solve this, you're not going to like this, but it's
Do
what it
we
is.
even need to know that? If not,
Just know to switch it or flip-flop this. So if I say, what is the probability of B given that A occurred? Really, I just revamp the formula to say that it's the probability of A and B, which is the intersection, divided by the probability of A equals probability of B given that A occurred. Correct?
would you have been given like probably A and B probably?
Correct.
Okay.
You probably be given the intersection on that to find that part. Okay. You could also do it if they weren't independent, and you say, for instance, if I have 52 cards in a deck, right, and I say the probability of A is a red card.
Yeah.
The probability of B is a 7. Okay. Are there red cards that are 7? Yes. So what if I said, what is the probability of A given that B occurred? Okay. So what is that saying? B occurred, right?
Yeah.
I have a 7. How many 7s are there? 4 7s, right? So if you think about it, I've got 4 different 7s that are there. That's given. That is like set in stone. So based on that, what is the probability that there will be a red card?
2 out of 4.
2 out of 4, which is 1/2. Does that make sense?
Mhm.
Okay. So that would be what we would say there. Correct. Alrighty. Any other topics? I know we're just kind of going here. We've hit a lot, haven't we?
Yes.
It's good. Is this better than talking through like a ton of problems, like just going over topics, or
Yeah.
So,
we could probably do a little bit of both as we continue through these
Can
podcasts
you
here.
just write the formula for the least squares regression line again?
Yeah,
That's
absolutely.
my question.
Y hat, which is the predicted of y,
Mhm.
equals my slope which is m, okay, times x. X is the variable, right? M is the slope, plus b. So it's kind of like y equals mx plus b right here. When we have a context of a problem, for instance, are you still on the
Can you do like 16? I want to know how like when you're
16?
looking at the little, what do they call that thing? The like where it has all those like numbers and you
Yeah.
can find the slope.
Yeah, absolutely. So on number 16, okay, yeah, how to like looking at what was it called again? The something table,
Yeah.
and I'm forgetting what it's called.
I forgot what it's called
like-
too.
Is it data table? That seems too basic. But regardless, on 16, they give you this information of this box of all these values, right? And so the question is based upon this information on 16, what is the equation that's related to from that table? So to kind of remind ourselves, remember the key is that the whatever that has the hat on it, that's the change in y, right? Okay. So first off, we can eliminate a couple of them because what's the y-axis?
It's
Yeah, it's the eggs, right? So if I were to write this, my eggs would be the y part because this is my y-axis. Does that make sense? And then what's my x-axis?
the length of
The length, right? Okay, so we can eliminate D and E, right? D and E can be eliminated. So the next question is what is the slope that's here? Okay, how can we find the slope over here? So what we can do is identify. I'm looking real quick, making sure I could.
Would B be ruled out because the slope is negative?
Correct. Yeah, B can be ruled out because that slope would be negative there, right? And I can't find the 39.25. Can you find that?
Yeah.
Let's see here. Or the 5.392. It's like this problem isn't even related to.
Yeah. Actually.
Oh man, that was messed up. Sorry about that. Those at home, my apology. My apology. Let me get this back on track. My fault. Okay. Let's look at because I think that might help us. That's what we're looking at here. Number 16, the answer was A. It says it's a computer output, so if we just say that, that's fine.
what is this problem for?
This is, if you want to look at it, you can. It's the equation of the least squares regression line. We know that this right here, what we have behind me, is stated, but what I'm not getting right now is I'm not finding those numbers. Does that make sense?
Yeah, usually like you would find
Do you usually give them y hat or no? Usually.
yeah, the y is like, so the y is eggs, and then the x is length, so you know it's like probably one of these, and then but the slope is negative, so it's probably one of these. But usually you would find the slope here.
It's not there, is it?
Yeah, no.
Here's what I can do. Let me do this. That was on chapter 3, I think. Let me look at it real quick. Let me pull something up and let's see what we got here. Sorry about that. I don't know what happened there. Let's look at it. All right, right now I'm pulling up chapter 3 right now. Hopefully this will help in terms of, I'm going to try to throw this up there on the board here. throw this up here. Okay, so what it's saying is I'm gonna actually put this on here because I think this will be really good just so that you can see. So you have it there. Okay, so based upon the information that I'm given, the standard deviation, the slope, let's talk about the slope first. The slope would always be the change in calories. Does that make sense? In terms of what was right below. So whatever's the coefficient, COEF, right there, the 0.06297 right there, that right there would be the slope, and the 2.08 would be my y-intercept. That's there. Does that make sense? The S, which is the 3.37 or 3.38, that's my standard deviation. That's there. And the r squared would be remember the equation? That'd be the r squared, which is the variation in y as it relates to the least squared regression line of x. That's like that definition that's really weird there. But that's how you would use that example that's there. And I just figured out what I did. Look at the definition. I'm sorry. 40 means what? Look at number 16. 40 means 40,000 eggs, right? So what does that mean in terms of my values? Do you see what I did there? So you would have to convert those within in terms of the number of eggs is given in thousands. We have to kind of write that down, and based upon that, that's how we would find what our the mean and that sort of thing is, the mean and the y-intercept. Okay. Now, if I looked at that output, the 0.062 would be or 0.063 would be my slope, and 2.08 would be my y-intercept. Okay. And that's how we would give it there. I'm looking to make it sure. Perfect. Am I making sense on that?
Yeah.
My apology, y'all. This would be our equation. If someone could help me with this too, I'm trying to figure out how they still got those numbers. You see what I'm saying? Note that number of eggs is given in thousands. So 40 means, I gotcha. So the mean of the slope of that. Oh, I gotcha. So what they're saying is that as the y increases, so slope is this, right? The slope would be 0.063. Got me? Over 1. That's slope. If you look at it, which is the calories right underneath the coefficient, right? So if that's true, that means that this rises 0.063 as it runs 1, right? So it rises this many eggs as 1 centimeter increases. But it's not this many eggs. It's this many eggs in thousands, right? So if we did 1, 2, 3, this would be 63 over 1. And so as we increased 63-ish eggs, we run 1. Still not 1 that's there. I'm still wondering where they got that. They run 1 centimeter. Someone could figure that out. Bring it to me. Who knows what I might do. Give you a point or something on the exam. Could. So yeah, bring that to me. I'm not sure how they got these numbers. It looks as though the computer output is almost unrelated to what I see here. But you could check me on that and see, and go from there. I'm trying to figure that out. For some reason that not coming to me. It looks as though it's completely separate. But does that make sense though in terms of finding your output at least?
Yes.
That's what I wanted to at least be. That's the important part. Okay. Do y'all have any other questions in regards to other stuff that you see there?
Not really any right now.
Okay.
Really just continue to watch the podcast and you go over my test.
Gotcha. Tomorrow I've got 2 podcasts.
Okay.
One that I'm going to do, well, really 1 podcast and 2 study sessions. One that would be in my room at the same time, and the second one will be at the Peachtree Corners Panera. And I'm just going to do that from like 3:15 to like 4:45, I think I said, or like 5. But we'll throw that up and go from there.
Also, what other stuff should we go over today? We went over like Season 7. We went over least regression line.
Yeah, so we went through chapter 5 was probability. We hit mutually exclusive and independence pretty good.
Yeah.
We didn't go through everything, but we hit that pretty hard. Chapter 6 was like binomial. We addressed that a little bit. We went through normal distributions, which was like chapter 2, I believe. Chapter 2. We went through chapter 7 by doing a sampling distribution and approximating the same distribution with a normal curve, right? Or a normal distribution. We also went through, that was quite a bit. That's kind of all I remember. We went through a little bit of the least squared regression line, though the numbers for some reason I couldn't match up or couldn't get it equal there. But if someone could correct me on that, you can bring that to me on that, okay?
Okay.
Other than that, y'all, this was a good time. Hopefully this was helpful for
Thank
you.
you so much.
And I appreciate y'all for coming. And have a good one. Bye.